We have this paragraph question here. So there is a paragraph given and there are two questions based on it. Let's see them one by one. So the statement says that you have f1 and f2, where the coordinates they are telling x coordinate is first one negative and second one is positive. Be the foci of the ellipse. Okay, so let's draw the ellipse. One is here. You see that they're saying x1 is negative. So here you have f1 and here you have f2. Suppose a parabola having vertex at the origin and focus at f2. So let's draw a parabola also. So parabola might be looking like this. Okay, so it is intersecting the ellipse at the point M in the first quadrant and N in the second quadrant. Okay, now they're asking you orthocenter of the triangle F1MN. So where is F1? Okay, so this is your F1MN. So they are looking for orthocenter of this triangle. So of course, for doing that, you have to know what is F1, right? What is M, what is N, everything you need to know. So let's work with the foci first. What is the focus? Okay, what's the coordinate of the focus? You know that? Yeah, both the focus, A plus minus AE comma 0. Okay, A you already know, that's 3. Okay, under root of 9, that's 3. E you don't know, and you can figure out, right? You know the formula for the eccentricity, 1 minus b squared by a squared. So what is it in our case? 1 minus b squared is 8, right? Sitting here, that's b squared. Upon a squared, that's 9. So you get under root 1 over 9, that's 1 over 3. So can I write my focus now? Plus minus a value is 3 under root of 9. Okay, and a e. So you get this is plus or minus 1 and then 0. So you got both the focus, right? So here this is negative 1 and 0, and this one you got to be positive 1 and 0. What is left? Finding m and n. That is not a problem at all, right? Because okay, so what's the equation of the parabola? Because parabola equation, there's a center, like vertex is at origin, so it should look like 4ax. And they just now said that your focus is this is the focus, right? F2 is the focus this side, and F2 coordinate you got to be 1 comma 0. So a is your 1. So your equation of the parabola you got is y square is 4x. That's the equation of parabola. So to get m and n, you just need to solve the ellipse and the parabola, as simple as that. So let's do that. So x square upon 9 plus y square value I'm going to put, because it's also on the parabola intersection point we are going to take. This is equal to solve, okay, ellipse and parabola. So what are we getting? So let's see what equation do we form. We get 2x square plus 9x minus 18 is equal to 0. Factorization looks simple because I think 12 and 3 would work. So 12x minus 3x minus 18 is equal to 0. So simply take 2x common. I know you can do that. So this is minus 3x plus 6 is equal to 0. So you get two values for x. Okay, one is negative 6 and other is 3 by 2. Okay, 3 by 2 and negative 6. Of course, negative number you're not going to take because y square cannot be negative, because to get the y value you have to do 4x. Okay, so I will use 3 by 2. So you are getting this is 6. So y is equal to plus or minus root 6. Okay, so x is this. So we got the intersection point, right? What are they? X value is 3 by 2 and y value is root 6 for m. And here also if you want you can write 3 by 2 and minus root 6. Everything is not known to you. Now you have to figure out the orthocenter. What's the orthocenter? Now do you see that this triangle they are talking about F1MN? Okay, this triangle. This is an isosceles triangle, right? This and this are same. F1M and F1N are the same. Okay, so do you think that this is already perpendicular? Like F1, F2, the line passing, let's call this something N. Okay, F1N is already perpendicular to MN. Okay, now orthocenter should lie on this only, right? The point where the altitudes meet, that is the orthocenter. Okay, so it should lie on this line, so definitely on the x-axis. What I will do is to get precisely where is that point, I will draw a perpendicular from M onto uh, F1N. Let's draw that. Okay, like this. Okay, I have drawn. Let's say the point where it meets the x-axis. Okay, that should be orthocenter. Understand? Okay, the points where altitudes meet, that is the orthocenter. Okay, I am dropping perpendicular from M to the opposite line. Okay, F1N. So the point where it is meeting the x-axis, let me call it P. That is my orthocenter. Okay, now I will assume a coordinate, because y coordinate is 0. Let's say x coordinate is alpha and y coordinate is 0. This is my orthocenter. I need to figure out what is P. Okay, let's do that. Now, since we have dropped MP is perpendicular to F. Okay, let me write MP. Okay, so MP is perpendicular to F1N, correct? Okay, let's get the slope of both of them, because if you get the slope for both of them, you know M1, M2 should be -1. Okay, so what is the slope of F1N? Yeah, quickly figure out. Y2 minus Y1, right? So Y2 minus Y1 upon x2 minus x1, correct? That's the slope of f1n. Now what you are getting? This upon 3 upon 2 plus 1, that's what? 5 upon 2. Okay, so this this is the slope. Okay, now figure out the slope of this mp. Yeah, again y2 minus y1, root 6 minus 0, right? This is okay, this minus, I mean slope you're getting from these 2 points. Root 6 minus 0 upon 3 upon 2 minus alpha. Okay, this. Now you know the product of these two should be -1. Let's do that. So product of root 6 upon 3 by 2 minus alpha times minus 2 root 6 upon 5, that should be -1. That should give you alpha, right? Let's solve it off. Okay, this is 1 1, I mean -1 you can cancel off. So you get 2 times 6, that's 12. 12 is equal to 5 times 3 upon 2 minus alpha. Let's figure that out. So 12 upon 5 minus 3 upon 2, that should be equal to minus alpha. Solve it for alpha. I'm doing it here, don't mind. So 10 I will take as an LCM, and what I'm getting, 24, right? So minus 24 and plus 15. Okay, how much is that? 5 and 4, 9. Okay, so negative 9 over 10. Okay, so my p was alpha and 0, right? So minus 9 upon 10 comma 0, that's my orthocenter. Okay, so yeah, option matches, right? So A is the correct option. Let's look at the second question. Second question is saying that if the tangents to the ellipse at M and N meet at R. Okay, let's draw that. Okay, so tangents at M and N to the ellipse. Okay, so ellipse, I'm going to draw tangent. So tangent here and tangent here. Okay, they are meeting at R. Okay, of course by symmetry, you know, they are going to meet in the x-axis, right? So y coordinate is always 0. You have to figure out what's the x coordinate here. Okay, what is the normal to the parabola at M meets the x-axis at Q. Okay, so you have to draw a normal to the parabola. So this is my parabola. If I try drawing a normal to that Q, okay, still I don't know, because it is meeting in the x-axis. Again, the y coordinate is 0. I need to figure out what's the x coordinate again. Okay, let's read more. Then the ratio of the area of the triangle MQR. Okay, you can see, right, the triangle MQR, this triangle, to the area of the quadrilateral. Okay, this, look at where is this quadrilateral? M, this is M, F1, N, F2. Okay, so this quadrilateral quadrilateral they are talking about. Okay, this one. Okay, so the ratio of the area they are talking about. So of course we need to figure out both the areas. So let's see, first figure out what is R. Okay, let's see. Tangent equation, can you write tangent equation at M for this ellipse? Okay, point form of the tangent x1. So I'm just directly writing, if you don't mind, x1. Okay, x1 is the point. X1 upon 9 plus y1, okay, upon 8, that is equal to 1. That is equation of this tangent. Okay, tangent MR. Now to get R, can I plug in y is 0? Yes. So put y is equal to 0 to get the x coordinate on the tangent. Okay. So if I plug in y is 0, what I am getting? Let's see. So x into 3, 3 getting cancelled. X upon 6 plus 0 is 1, so I get x value to be 6. As simple as that. I got the x coordinate for r, so I got the r coordinate is 6 comma 0. Now can you work on q? This is normal. Can I write equation of normal? Okay, first get slope of tangent. Okay, what is empty? Slope of tangent to the parabola. Okay, what do you do? So your parabola, remember we said just now in the before question that the parabola is y square is 4x. I just find the derivative. Okay, 2y dy, you know, dy by dx is the slope, right? Do whichever way you want to figure out. You have to figure out the slope of the normal. So to start with, I am figuring out what is the slope of the tangent. This is the slope of the tangent. Okay, at the point M. Okay, let me just write M. So what do I get? Y coordinate for M is root 6. So 2 upon root 6. So what should be slope of the normal? Negative reciprocal. So minus root 6 by 2. Correct? Okay. Let's write equation of the normal now. Okay, point slope form y minus y1 is equal to m. Okay, I got this. This is the slope of the normal. M x minus x1. X1 I got to be 3 by 2. This is equation of the normal. Okay. Now what do I do to get q? Q is on the normal, also on the x-axis. Okay, so I again put y is 0. So put y is 0. Okay, if I put y is 0, what I'm getting? 0 minus root 6 is equal to minus root 6 upon 2 x minus 3 by 2. Okay, now just check it out. This gets cancelled. You are left with x minus 3 by 2 is equal to, I will take to the other side, 2. So you happen to get x to be 7 by 2. Done. Okay, even you got the q coordinate. It's 7 by 2. Now it's very easy. Let's figure out area of the triangle first. Okay, let me do on the top. So triangle MQR. What's the area? Half times base times height. Okay, what is height? This is, let me draw this. Okay, this is the height. Okay, let's call this point, what do I call? PQRS. Okay, MS. So what is your QR? See, this is 7 by 2 and this is 6. Okay, 6 minus 7 by 2, that's the length, right? So that's 5 by 2. Let me just directly write 5 by 2. Okay, 6 minus 7 by 2, understand, right? Yeah, QR. Okay, how much is the height? The y coordinate is the height of M, I mean height of M, MS. That's root 6. Okay, so you got the area to be 5 root 6 by 4. Correct? As simple as that. Now let's work on the area of the quadrilateral. Okay, this whole area. Let me just highlight that, this whole area. Okay, this whole area. Okay. So can you see that it is made up of two triangles, right? This is one triangle and the same triangle you are doubled up. Okay, so let's get area of this triangle and we will do twice of that. Okay, so for the quadrilateral MF1 and F2, okay, the area will be 2 times, okay, not the triangle, half times base. Okay, base is f1 f2, distance between 1 and minus 1, that's 2. Okay, so 2 base times height. Height is again, you see, the same. This is the height of this triangle, m f1 f2. Ms is the height. Ms is how much? Root 6. Okay, done. So how much do you end up in getting? 2 root 6. Now you have to get a ratio, right? This and this area. So this area, let me write it here. So triangle area divided by the quadrilateral area. Okay, so triangle area you got is 5 root 6 by 4, and this area, quadrilateral area, is 2 root 6. Simplify it. Root 6 I can cancel. I'm getting 5 upon 8. So the ratio is 5 is to 8. Let's check. Yeah. Okay, C option, right? C option says it's 5 is to 8, and that's the correct option. Okay, nice question. See you with another one.